Hi guys. Okay, so today we're going to look at inverses of trigonometric functions. Now before we look at the inverse of a trig function, we should probably review what an inverse function is in the first place. Remember, inverses are opposite operation, addition and subtraction, multiplication and division, squaring and square rooting, opposite operations, and they undo each other. So what's the opposite of a sine function? That's what we're looking for today. Now, when we find inverse functions, remember, we switch the x and y and then solve for y. And graphically, remember, they are reflections over the line y equals x, which you can see right there in the picture on this page. F of x is the red graph, and the inverse function f inverse of x is the blue graph. And notice the notation for inverse, remember, is f raised to the -1. That is not an exponent. You are not raising the function to the -1 and taking the reciprocal. That is not what an inverse function is. We do not say f raised to the -1. That is read f inverse of x. Okay? All right. So let's go a little bit into the trig now. So for instance, if we start with y equals sine x, and then we want to find its inverse, we switch the x and y, and we come up with x equals sine y. Now we're supposed to solve for y. And this is where we get stuck, because how do I solve for y? So we had to invent a new notation, and this is where the new notation comes in. When we solve for y, it's y equals sine inverse of x. So yes, it looks like you're writing sine raised to the -1 of x, but it is not really being raised to the -1. It is sine inverse of x. Or another notation that's used, partially to avoid confusion, and partially because remember, sine and cosine, we originally looked at them in the unit circle, and there are arc lengths on the round parts of this unit circle. Y equals the arc sine of x. It's the arc of the unit circle that would have a sine of x, okay? So y is the angle whose sine is x. When you see y equals sine inverse of x, that is saying y is the angle whose sine is x. For instance, let's look at an example. So we're going to rewrite the given statement without the word arc. So if theta equals arc sine of 1, that means theta is the angle whose sine is 1. So theta is the angle whose sine is 1. And that's all there is to it. Let's look at the next one. I'm going to put parentheses in here because this looks better. Okay, because of that negative. Theta equals arc cosine of -1/2. That means theta is the angle whose cosine is -1/2. So again, theta is the angle whose cosine is -1/2. That's it. Okay? Now let's try going the other way. So remember, if we have the cosine of an angle equals a number, that means that the angle is the arc cosine. Okay, because what we did is we did the inverse function. If you do the inverse of cosine on the left-hand side, the cosine goes away and all you have is the angle. And you do the inverse of cosine on the right-hand side and you have cosine inverse of the number, or you have arc cosine. Because remember, this can be written that way, or the angle equals cosine inverse of your number. Either way, they mean the same thing. So now, if we know that cosine theta equals 3/2, that means that theta is the angle whose cosine is 3/2. So theta equals arc cosine of 3/2. Good. One more. Tangent of theta equals 3/5. That means that my angle theta is the angle whose tangent is 3/5. So yes, it is also okay to write theta equals tan inverse of 3/5. These are equivalent, but the directions asked us to use the arctan form. Okay, so yes, they are equivalent, but we were specifically asked to use that particular form. Okay, so that's how it works algebraically, and we'll get more into evaluating in the next lesson. Right now, we just want to get to know what it is, and then we're going to look at it graphically. Okay, so graphically, we know that inverses are reflections over the line y equals x. So in the diagram, you can see we have a dotted graph of y equals sine x. We also have the line y equals x. And if you reflect it, you get that darker curve y equals arc sine x. When you look at that, this relation x equals sine y is not a function. It does not pass the vertical line test because the y-axis crosses it 1, 2, 3, 4, 5, but it's really going to pass it an infinite number of times because this graph keeps continuing in both directions. So it is definitely not passing the vertical line test. All right, so this inverse relation x equals sine y, which remember, y is the angle whose sine is x, or y is the arc whose sine is x, leads to the notation y equals arc sine x. Now, we're going to look at what this looks like graphically. So we're going to look at sine x in this video. We're just going to work with sine x. So the first thing we're going to do, we're going to sketch a graph of y equals sine x on the interval from negative 2 pi to 2 pi. So in my xy table here, I'm going to put a negative 2 pi, negative 3 pi over 2, negative pi over 2, 0, pi over 2, pi, 3 pi over 2, and I'm going to have to squeak in a 2 pi. And if we remember our special values, the sine, and if you want to start at 0, it's fine. Okay, the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2, or 270 degrees, is negative 1. The sine of 2 pi is also 0. And then if we follow it backwards, the sine of negative pi over 2, or negative 90 degrees, that's the same as the sine of 3 pi over 2, that's negative 1. And then 0, 1, and 0. So if we plot this, we have the points. Now remember, these are the points, negative 2 pi, comma 0, negative 3 pi over 2, comma 1. Okay, so I'm going to plot here, here, here. I'm just plotting all those points that we had. And then we're going to do our best to connect this with a smooth, rounded curve. Okay, and this is our graph of y equals sine x. Now I'm going to ask you two questions that aren't specifically asked for here, but let's find the domain of sine. Now I know in this problem I restricted the domain, okay, but in general the domain for sine is all of the reals, okay. Now the range, if you look, remember range are your y values, the graph goes down to negative 1 and up to 1, and it takes all y values in between. So now we're going to graph y equals sine inverse of x. Now remember, for an inverse function, we switch the x and y's. So notice what I did here in my table is I just switched the heading columns, y and x, which means the rest of my table stays exactly the same as it was above. All right, so rather than switch all the numbers, all I did is switch the names of the columns. I switched my x and y's. But we're going to have to remember before we try to plot this, that now this point is 0, negative 2 pi. It's 1, negative 3 pi over 2. And it's 0, negative pi. Okay? So when we try to plot this, that first one, 0, negative 2 pi, it's like off my grid here. Then I'm here at 1. I'm at 0 for negative pi. Then I'm at negative 1, negative pi over 2, 0, 0. Then I'm at 1 pi over 2, 0 pi, negative 1, 3 pi over 2, and 0, 2 pi. Again, off my graph here. But that's okay, because we know that the graph really continues forever anyway. So there's my graph, and this is my graph of y equals sine inverse of x, or y equals arc sine. Now notice I'm using a lowercase a and a lowercase s for the arc sine. That is important. Do not change the case. We'll talk more about why in a few minutes. Do not change the case of the letters. In math, capital and lowercase letters mean different things. If you think about geometry, lowercase a, b's, and c's in triangles were lengths of sides, where capital A, b's, and c's were angles. Okay, so the case of letters is very important. Now, if we look at this picture, the domain, that's our x's, how far left and how far right, it goes to the left -1 and only goes to the right 1. Now the range, this graph is going to keep going in both directions. So this range is all the reals. And if you look back at what we did on the sine, our domain was the reals and the range was -1 to 1. We reverse, you switch domain and range when you find the inverse. So this makes sense. It follows all of our rules. Okay, so now I want you to think about this. All right, this graph that we have for sine inverse, again, this is y equals sine inverse of x, or y equals lowercase arc sine of x, does not pass the vertical line test. This is not a function, okay? It is not a function. If we need an inverse that is a function, we need to restrict the domains of the original trig function in order to have an inverse that is a function, okay? So what we do, let me see if I can get a highlighter here, is see this little dark part right here. If we restrict it to just this part, we will now have a function. So if you look at this graph over here in the box, okay, this is f of x equals arc sine x, which is also sine inverse of x. Notice it starts here and stops here. That is a function. Now the domain on this is -1 less than equal x less than equal 1. And the range, -pi/2 less than equal y less than equal pi/2. Okay? So the angles, and I want you to think about these angles. It's going from, and if you think about when we rotate our angles here, from 0 to pi/2, this is quadrant 1 where sine is positive. Now if we kept going into quadrant 2, sine is positive again. That wouldn't give us any negative values. So instead of keep going, we go in the other direction into quadrant 4, okay, down to -pi/2, because in the fourth quadrant, sine values are negative. And that's why we restrict it to quadrants 1 and 2, because they're two quadrants that are next to each other where you will have positive sine values and negative sine values, okay? So this over here, you have the inverse of the sine graph, okay? But it's not a function. Over here, we have the inverse function, okay? So this is an inverse. This is the inverse function. There are no restrictions on domain and range here on the inverse. And for the inverse function, we have restrictions on the domain and range, okay? And I want to review really quick the notation that goes along with these restrictions and no restrictions. So if we look at the notation for the not restricted, which is the one that we started with, that's y equals arc sine of x, or you can see it as y equals sine inverse of x. Notice both of these are y equals. Now the restricted is y equals capital arc sine of x. So that capital A means we've restricted the domain so that we have a function. And the other way to write it is f of x equals sine inverse of x. So If we have a y equals on sine inverse, it's not a function. It's not restricted. If it's f of x equals, we have restricted it to be an inverse function. If we have y equals the lowercase arc sine, it's not restricted. If we have y equals the capital A, that's restricted. If you have f of x equals arc sine x, that is also the restricted, because that f of x is the notation for a function. Okay, so those are the different ways we can look at and write the inverse of the sine function and the inverse function for the sine function. And we will look further at more inverses, and we will look at cosine and tangent in class. And I hope you guys have a good day. Bye, guys.